Hi friends, today in this video we shall learn in details about what is population and what is sample. So let us start guys. So have an example of comparison between population and sample. Population means the number of people residing in a given geographical area. This is the definition that we get in the dictionary. In dictionary, population is explained in this way. But in the field of research, population is considered to be a little bit different. Here we consider the aggregate, that means the totality of the entire group of items or subjects on which we want to perform our study. For example, if we want to study the consumption pattern of a group of people residing in a particular area, then that entire group of people on whom we want to perform the study comprises of our population. So here, every unit of the population is individual. So all the individuals residing in the said geographical area for which we want to study, that becomes our population. But things changes soon. Suppose we are interested to know the consumption pattern of households of a given area. Just little bit change, that instead of individuals here we are using households. In that case, all the households belonging to that particular geographical area comprises of my population. And here each unit of the population is a household. Individual unit of a population is a household. Beyond that, we cannot break the households, because if we break the households, our purpose of a survey will be diluted. Purpose of our study will be diluted, because then we will be going to individuals and not remaining to households. But our study relates that the study should be about the households. Suppose we are interested in knowing the vegetation of a particular forest. That in a particular forest, what are the different types of vegetables that are there? What are the types of plants that are growing in this particular forest? This type of things. When we want to study, then each individual plant of a particular forest, tree, maybe herb, maybe shrub, whatever, this entire collection is our population. So it does not mean that population relates to people here. So it may have different dimensions based on the study topic. The total number of units in the population is called as the population size. Suppose in my population, suppose I am interested in knowing the type of way in which students approach their exam in a particular institution. Then all the students of this institution studying under all the different programs, they make or comprise of our population, and the number of such students, all the students, that is called as the population size. In studies related to population and sampling and in research, population is commonly represented by capital N, which represents the population size. Sampling is the process of learning about the population characteristic on the basis of a part of the population which is drawn from the population itself. That means sample, we are trying to learn about the population characteristics, that what is the average income, what is the average expenditure, or what is the way in which the students are approaching their exam. This we want to know, but instead of studying all the units of the sample, we are sorry, all the units of the population, we are selecting a group of individuals from the population, or group of sampling units from the population. This small group is expected to represent the population. So we take a representative sample from the population, and based on studying that particular sample, we try to understand what are the characteristics of the population. So that is the difference between a sample and a population. This part which we consider from the population, that part is called as the sample. But remember, here sample may not be any part of the population. What we want to do in the sample is to make the sample a representative part of the population. The sample is selected in such a way that all the characteristics of the population are embedded in it. So that is one very interesting thing, that we expect that the sample represents the characteristic of the population. Now, my dear, this will happen only if we try to make a representative sample. That means we try to select the sample in such a way that all the characteristics of the population are also reflected in the sample. And then we can actually study the population characteristics through the sample. The units of the sample are studied instead of the population, and inferences are drawn on the characteristic of population based on the sample. So here you see we have a big responsibility that we study a sample and we take a inference on the population based on sample characteristics. Let us take some examples in order to understand this very simply. For example, suppose me and some of my friends we go to a picnic. So in the picnic, we actually decided that we will cook our food in the picnic spot itself. Instead of taking a packed lunch, we have decided this. So we carried some utensils, some fuel so that we can light fire and boil our food, etc. We went there. So at the very beginning, we decided to let us cook the base, that is, let us cook rice, so that whatever other vegetables or non-veg item we'll cook later on, we can eat with this rice, with rice being the staple food. So I lit up the fire and I started boiling some water where I will later on pour rice and boil the rice. So water got heated, it started boiling, and then I poured washed rice into the saucepan in which I am cooking so that I can see how it gets boiled. Fortunately, we have few number of means quite a large group of people, and the pressure cooker would not be sufficient for cooking rice for all the people. So we had to take a saucepan for that purpose. Now I can see that the rice after some time started boiling in the saucepan, and I waited and then it boiled more. And now I want to check whether the rice has got boiled properly or not. So what I do is that I take a big spoon, and with the help of the spoon I pick up few grains of rice, and then I press it between my fingers to check out whether the rice has got boiled properly or not. Now in this process, this we can compare with a population and a sample. The rice that is being boiled, the entire collection of rice that is boiling now, that is the population, and the rice that is in the spoon, that which I have picked up and I am pressing between the fingers, that is sample. Now we want the sample to represent the population. That means the rice taken in the spoon and the rice that is boiling in the pan, both of them should have the same characteristics. That means they should be equally boiled. We assume that it is equally boiled, and actually it happens also. So in, if you cook rice in a saucepan, because there is a rice, you watch that the rice is coming down, going up, coming down, going up, so it is getting uniformly heated all around. Now these we are actually pressing the few grains of rice between our fingers and taking decision about the entire pan of rice. That means we are studying a sample, but based on the study of the sample, we are drawing the inferences on the population, that is the entire collection of rice. So if I am satisfied, I will tell that yes, now the rice has get boiled. So let us take the help of some other friends and try to put it outside the fire and drain the water out so that I can get completely boiled rice, and later on I can eat it with vegetables and all. So I go to the next step of cooking the vegetables. When I do cook the vegetables or the non-veg item, I repeat this technique again and again to check what is going on in the pan or what is going on in the frying pan. So this is, or in the saucepan, what is going on in the saucepan. So this process of studying a sample and taking inference about the population or drawing inference of the population about the population, that is the purpose of this particular study, and that is what the sample is doing. So sample is doing a great job for us, because based on the studying the sample, we are drawing inferences on the characteristics of the population. Let us go to the next slide. Here we are to understand the difference between a parameter and a statistic. Now, whenever we study a population, there are some characteristics of the population on which our interest lies. That means we want to know the maximum observation in the population. We may be interested in knowing the average of the observation, average in the population. What is the average in the population? We may be interested in knowing the variation in the population. But since we are not studying the entire population at one go, so we are not quite sure about the value, these values like population mean, population variance, maximum value in the population, etc. Such values, which are characteristics of the population, are called as parameters. The parameters are characteristics derived from population quantities and they are constant. Now, if I know all the values in the population, then we study all the values in the population and we can find out the population mean, population variance, maximum value of the population, minimum value of the population, etc. Now, when I know all these values of the population, these are called as the values of the parameters. And the value of the parameter is fixed for a given population, because in the population there is no new entry or no exit. So in this population, when we perform the study, whoever are the members, they have this value. For at that point of time, later on population values might change, but for at that point of time, that is the value of population mean, population variance, etc., and it is believed to be constant. We have the notation of the different characteristics of the population, and these notations are generally Greek letter in smaller case. For example, we have notation population mean as mu, population variance as sigma square, population correlation coefficient as rho. All these things are actually written in small letters but Greek letters. So that is one representation just for the purpose. On the other hand, statistics are based on sample observations. So when we study the sample, based on sample observations, we calculate some values. So those are called as statistics. Values of the statistic vary from sample to sample even if they are collected from the same population. For example, you go and you collect a sample of students. I also go to the same class where you went and collect another sample of students. Now, our samples will in general be different from each other. Some sampling units, some students might be same in both the samples. Some common students might be there in both the samples, but some uncommon students will also be there. That is the generality. Means in a particular case, both the samples may be same, but that is a very particular case. Otherwise, our samples will be different. And since our samples will be different, so say sample characteristics like say sample mean, sample variance, sample standard deviation, minimum value in the sample, maximum value of the sample, etc., that you have derived and that I have obtained from my sample will not match. They are expected to be different. They may be close, but they will not be equal in general speaking. So the values of the statistic are different even though collected from the same population at the same point of time. This statistic is used as an estimate of the population parameter. That means if we calculate the value of the statistic from a sample, then using that we can get an estimate of the population parameter. And the statistics are represented by small Latin letters like mean. Sample mean is written as x bar, sample variance is written as small s square. Like this we generally represent that by small Latin letters. Some exception are there. For example, sample standard error is represented by capital S square. Capital S. So there is sometimes we use capital Latin letter also, but never Greek letters for representing sampling characteristic, that is statistic. Let us go and look into different types of population that we generally encounter in different research. First is the finite population. In a finite population, the population is fixed and they are limited to a particular number. Say number of students in a class, number of students in a college, like this. These are actually limited number of students, and we generally know the population units can be identified and we know what is the size of the population. So these are called as the finite population. And obviously since there is a finite population, there will be an infinite population also. So in an infinite population, we are not aware about the sample size, or the sample size is very large. For example, number of stars in the night sky. When you look at a clear night sky, we find that huge number of stars are there, simply uncountable. So these comprises of an infinite population. Sometimes the population, when the population is too large, maybe having a finite number, but That is too large. And that number also we don't know how large it is, what is the value we don't know. Then also such populations are termed as infinite population. After that, we have another division, and that is considered as the real population and the hypothetical population. In real population, the members of the population, each of them really exists in reality. They can be contacted and information can be collected from them at that instant. So these are called as real population. For example, automobile companies in a country. So in a country, there will be not very large number of automobile companies. Even if they are large number, that doesn't matter in this case. But the population is real. Means company has an address, they have a location, they have a CEO or a manager whom you can contact, collect the information, or at least they have some identity. They can be traced. So this is an example of real population. Next, we come across another and type of population opposite to that of real population, and that is hypothetical population. Hypothetical population is a population which does not exist now physically, but in days to come they will come into existence. That means often you hear about planned cities, that we are making a planned city. This is a planned city. Chandigarh is a planned city. Bengaluru is a planned city. So what is the concept of planned city? Planned city actually looks into sustainable development. The city is planned in such a way that it can accommodate the population growth, because with time to come population will grow, offices will come up, more number of uh, buildings will be built, trees will be cut down. So there is way in which they can be compensated by planting further trees wherever there is some accommodation. Even in the streets you will find that they in their separators trees are being planted, so that the trees that are sacrificed for the purpose of building roads etc are compensated in a number of ways. So what happens with time, many things will change, but you have taken account of all these changes, and hence the city is a planned city. Things are planned in a proper way so that it can include the growth in the population. Now when you speak about the growth of the population, that population which will come into existence, that number of automobiles will which will come into existence after 10 years, after a period of 10 years, is not currently physically present before you now, but in due course of time they will definitely come into existence. Such are examples of hypothetical population. Here we have cited an example: foreign companies that will start business in India in the next 10 years. Already some foreign companies are there, but in next 10 years might be some more companies join. So you have to think of those companies coming in. So those companies will come in the next 10 years. Those companies are my hypothetical population. Currently I don't know who they are, and they are not existing currently, but in days to come they will come into existence, and come into existence surely. So that is an example of an hypothetical population. Another way of differentiating a population is animate population and inanimate population. In inanimate population, the population comprises of living things like maybe human beings, maybe animal, cattle, maybe insects, maybe plants, etc. So when your population comprises of any such thing which has life, then it is called as animate population. And inanimate population comprises of those population in which the members are non-living things, like a collection of desktop computers in a particular institution. So someone wants to perform a study on the desktop computers that are available in an organization, so that there is a purpose, might be like they might be interested to dispose this computer, so that they can replace this by laptop computers etc. So for that purpose they actually are trying to get it done by replacement. So to do this, they are actually looking at study, and here the population is all desktop computers of that organization. Since computers don't have life, so they come under inanimate population. We go to the next part, and that is the census enquiry. That means when we study the population, we mean to say that we actually study all the units of the population. So any such study in which all the sampling units of the population are visited and the study is performed, this study is called as the census enquiry. So census inquiry, we take decision about the different parameters of the population and based on the study that we perform. For example, we may be interested to know the number of children in each family for a particular geographical area. So all the families in that particular geographical area comprises of my population, and I visit each of the families and I take a note of the number of children in these families, and then I tell that okay, in this particular area the number of average number of children per family is 3.2. So that is the population characteristic attained through census inquiry. If the population size is large, a census inquiry may involve large number of people, and this may be spread over a large time period. For example, simple example is say census in our country. India is a large country having lot of diversity, lot of languages. Uh, Given the geographical diversity is also there, so we have to involve a large number of people for performing this survey. Some as investigators, some as field workers, some making the schedules ready, some people making the sampling units listed, some people doing the actual survey in the field, some people giving them training, some people receiving the results, some people entering the results into the computer, some people doing the compiling. So this is a huge task, huge task. So obviously large number of people will be. When you think of involving large number of people, you have to compromise with expertise. That means you have to, as in you have seen in the census, who generally comes to collect data from your home, it is some teacher. It is some teacher of a primary school. They are given the responsibility, they do their duty. Now their actually basic responsibility is teaching. They teach the students, they teach the children. But this data collection, they are taught through training, and hence they come to our houses and collect the data. Now this is their not their primary job, so some amount of compromise we have to do with the quality when the quantity is large. So that happens in generally in census inquiries. However, if the size is small, population size is small, we don't have to worry so much, but generally the population sizes are large. Next we have the these findings of the census is fixed because it is constant over a particular period of time for that population. However, there might be errors of high magnitude, because here there are two types of error. One is sampling in surveys, one is sampling error, and another is non-sampling error. Since in census survey no sampling is done, so there is no question of sampling error, but the non-sampling error can be of high magnitude. We can diminish the non-sampling error by using proper training to the investigators and proper supervision of the work that is being done. So there are some ways and means in which we can decrease the magnitude of non-sampling error which exists in census inquiry. Census inquiry, the non-sampling error that exists is often difficult to estimate. Uh, and also such inquiry is not possible if the sampling units are destructive. For example, suppose I have a collection of crackers at my home. I may be a businessman of crackers and I have a huge collection of crackers in my home. Now I purchased it last year, and this Diwali I want to offer it to the retailers for selling. Now the retailers come to my home and I express, honest businessman, I express that actually this is not this year's product, it is last year's product. Now the retailers may want to check it out. But let us check whether it is really of good quality, or during the monsoon season it got moisture and got destructed, or not performance level has gone down. So for that purpose they are burning some crackers and checking it out whether it is of good quality. Now here testing is destructive, because if you burn the crackers are actually spoiled, they are gone forever. You cannot repeat it. If it is bulb, then fine, you switch it on, check its luminous intensity, check whether it is giving proper performance, and then next you can go for another, you can go for selling the same product. But this is not possible for crackers because it is destructive. So any such thing which is destructive in nature, cannot be performed, a census inquiry cannot be performed on that. For example, blood in our body, it is a homogeneous fluid, so we often go to the doctor and doctor asks us to go to blood for blood test, and our blood is tested. Now this is a destructive uh, process, because once the blood is out of your body and tested, it is not the same blood which went out of your body, so it is not again injected back into your body, but here testing is destructive, so we cannot think of a census inquiry. We have to go for a sample inquiry or a sample survey. Now let us look at what is sample survey. Obviously, by this time you must have understood that when we study a sample or perform a survey on the sample, then it is called as the sample survey. So a representative sample of observations are collected from the population and are investigated. So this is called as a sample survey or a sample investigation. Uh, the volume of the inquiry is relatively less, and so trained personnel can be involved. So this is one advantage that you have in sample survey, because from the population you select a representative sample, a small group, and your study is subjected to that small group. So the volume of inquiry is relatively less compared to the studying of the population, and since it is relatively less, so you can involve experts, you can involve trained personnel for that purpose. And so accordingly, when you involve trained personnel, the amount of error, that is non-sampling error, will decrease. These results that we have obtained from the sample study is not actually used for the sample, but these results are used for generalizing or to estimate population characteristics. For that means if we study a sample, these sample observations can be utilized, or say sample characteristics like sample mean can be utilized to estimate the population mean, or sample mean and variance can be used together in unison to estimate the confidence interval for the population mean. That means an interval estimate for the population mean, that the population mean must be lying between this value to this value, since sample mean is this and sample variance is this. So we can use sample characteristics to estimate population characteristics. That means we can use the statistic for estimating the parameter, and the process comes out through the sample survey. Now in sample survey are actually exposed to both sampling and non-sampling error. So what is sampling error? When we select a sample, our inferences are based on that sample only. We don't know what is happening beyond the sample, the units which we have not studied. So some amount of error will automatically creep in, because we are studying a small part of the population and taking a decision on that. So that is why we have sampling error. Non-sampling error actually are those which are not because of the sample, but because of some other reasons. For example, my investigators were reluctant. The method that I used for data collection is not appropriate. The time in which the data was collected, actually people were too busy and were not very attentive in giving the research, or means the survey was quite long and we did not give any compensation to the respondent, like money or some sweet or some food. So they were actually not very reluctant in giving the response. So these type of errors are called as non-sampling errors. Such errors are common to both census inquiry and in sample survey. But in census inquiry, the magnitude may be more, but in sampling we can actually control the non-sampling error by training the investigator, because we are having a small group, giving some compensation also, because that will become a very large if we start giving compensation in case of census inquiry, because the size is very large, the number of people surveyed are very large, but in sample the number of people surveyed are small. So accordingly, I can give more compensation, or yeah, I can do this compensation business with a less amount of resources. So that's why the non-sampling error can be diminished to a great extent in sample studies, and the the sampling error can also be diminished, not zero, but diminished by choosing the appropriate sampling technique. So what are the different sampling techniques that we will see in due course of time? For the time being, I would like to thank all of you for watching the video. So thank you.